Okay, here we are asked to evaluate the expansion work. The problem goes, a gas in a piston cylinder assembly undergoes an expansion process for which the relationship between the pressure and the volume is given by PVN equal to a constant. The initial pressure is 3 bar and the initial volume is zero point 0.1 and it will expand to a final volume of zero point 0.2 m cube. And we are asked here to determine the work for the process in kilojoule if n is equal to 1.5 and the other one if n is equal to 1. Essentially, PV to the n is a constant is a what we call polytropic process, and the special cases for that, if n is equal to gamma, which is simply Cp over Cv, normally for air and other polyatomic material or gases, it will be equal to 1.4. We call that process PV to the 1.4 is equal to we call this isentropic. This happens during adiabatic reversible process. But anyway, in this case, we are trying to solve for n equal to 1.5 and n equal to 1. So let me just sketch here a rough version of the problem. Okay, so we have here like the gas is inside this piston, the cylinder where we have here the piston where the gas will push, okay? The gas will push so that it could expand, which we'll have an idea that the gas do work to the surrounding, okay? Since the gas is the one pushing the piston, that it will move out. So work essentially here will be negative because we're using the convention that when work is negative, that means that work is being done by the system to the surrounding. So initial pressure is 3 bar, volume is zero point 0.1 m cube, and V2 will be zero point 0.2 m cube. Okay, so how do we solve this? Well, it's just very simple. To get this expansion work, we'll just be using the equation work is equal to the integral of negative integral of PdV. Okay, and the idea here is we cannot integrate PdV directly because we don't know. We must be able to express P in terms of V, right? So in this case, since we know this, PV gamma at PV to the n is a constant. In this case, first problem, let's work with when n is equal to 1.5, okay? So in this case, when n is equal to 1.5, we'll then be having PV to the 1.5 is equal to a constant k. Let's represent constant with k. And from here, one could actually solve for P in terms of V, right? Since k is a constant, one could write that P is simply equal to k over V to the 1.5, okay? And therefore, the work in this case, okay, work from here will simply be equal to now to negative, where P is k over V to the 1.5, V to the 1.5 dV. Okay, and how do you integrate that? Of course, we integrate this from two limits, from V1 to V2, where we already know what is our V1. It's 0.1, V2 is 0.2. Okay, and k is a constant. We'll just factor that out first. What will happen? Okay, and the integral will be, okay, this one could be thought of v to the negative 1.5, right? So we'll have the integral of that will just be equal to v to the negative 1.5, add mo na yung 1, so we'll have v to the zero point 0.5, okay? Then divide mo siya by negative zero point 0.5, then evaluate mo from v1 to v2. Okay, in this case, then this will cancel the negative, we'll then be getting 2k, and then this one will just be, if you evaluate that, we'll have v2 raised to the negative zero point 0.5 minus v1 raised to the negative zero point 0.5, right? And I think we know v2 and v1. So I think the only problem here is the k. What is k in this case? So since k is a constant, we can actually evaluate it at any given. In this example, k could be evaluated from the given p1 and v1. So let's evaluate k. In this case, p v to the 1.5. So if we just use the first condition, p1 and v1, so we'll have p1 3 bar. But I'm putting here in terms of Pascal because Pascal is standard SI unit for pressure. So that's 3.0 times 10 to the 5. That's 100,000, right? Pascal is a bar, so that's Pascal. And then v will be in m cube, so 0.1 m cubed raised to the 1.5. And actually here, K will then be equal to 9486.83 Pascal, and this will be what? M cubed raised to the 1.5. So 3 times 1.5, that's equal to 4.5 m raised to the 4.5. Okay, now we could directly substitute that here. So 2 times that, 9486.83. Okay, I'm not writing the unit anymore. Times what? V2 minus V1. So V2, which is I know, 0.2. V1 is 0.1 raised to negative 0.5. Okay, that gives me negative. So I'm doing it directly. Okay, I'm putting the values, the result for this one. Negative 0.926. Okay, negative 0.926. Okay, and therefore work in this case will be equal to, so this is, ang unit nito will be, let me check. The unit for this is Pascal. So we'll see what will be the unit. Pascal to the 4.5, and this one the unit will be um okay, in this case, right, the unit of volume, this is volume to the negative 0.5. Volume is m cubed raised to the negative 0.5. So yung unit nito mismo is m, so cube times 0.5. So it will be negative 1.5. Okay? Pag nag-multiply ka ng ganyan, of course, the final unit mo will become Pascal m cube. Okay? So in that case, that will become 9486 times this one and that one will be negative 17,569 Pascal m cube. Okay, Pascal m cube, or Pascal m cube is just joule. Okay, standard SI unit for work. Pascal m cube, joule. In this case, since we are being asked for in terms of kilojoule, therefore the answer for this one will just be, therefore, okay, let's put here, therefore work is equal to negative 17.6 kilojoule. Okay, kasi nga kilo, so I'm putting there a, you know, I'm putting there a divided by 1000. Okay, or this is actually, or this is a unit of joule. Okay. Okay, now our next question will be when n is equal to 1. So what will happen when n is equal to 1? So in this case, let's try to work that out. N equal to 1. Let's also solve for the work. Okay, so in that case, what will just be the difference is that in here, PV will then become PV to the n will become PV equal to K. Okay, and we can then simply put in there P is equal to K over V. And when we evaluate work for that will then be equal to negative integral of K dV over V. Of course, from V1 to V2. And the only difference here when n is equal to 1, because the integral of that will then become what? Ln, right? This is not just, you add 1, because it will become, negative 1 plus 1 will become 0. And we cannot divide it by 0, so this will just become what? Negative K ln of V2 over V1. Okay? Yeah, negative K ln of V2 over V1. And then solve for K. In this case, K will just be, well, it's easy to solve for K because you could just use the P1, which in this case, P1 is 1 bar, so, no, 3 bar, so 3 times 10 to the 5, that's in Pascal. I'm converting the bar to Pascal, and V, the initial volume, okay? So because we could just either put here K equal to P1 V1 or any combination P2 V2, but since we don't know P2, it will be easy to use P1 V1, okay? And the volume is 0.1, okay, 0.1 m cubed, and therefore it's clear that the K will just be 3 times 10 to the 4 Pascal m cubed, okay? And Pascal m cubed is actually a unit of, you can just have that as joule. Yeah, joule lang yan, di ba? Pascal m cubed, that's a standard unit of work, or that's equal to joule. Now, negative K ln V2, so we'll have here 3 times 10 to the 4 joule, okay, multiplied by what? ln of what's V2? Well, V2 in this case, it will expand to a final volume of 0.2 m cubed. Okay, so V2 will be 0.2 m cubed, while the V1 is 0.1 m cubed. Okay, wait, I think I forgot the negative. Okay, I'll write that there, and therefore here we'll be getting a value of, so work in this case will just then be equal to negative 20,794.4 joule, or in terms of kilojoule, this will just be negative 20.8 or 79. Let me put 79. 20.79 kilojoule. So from the first given, we get as negative 17.6. Here we got negative 20.79, meaning if that will be the case, this will do more work than the first one. Okay, so in this case, we are just having this, and I think hope that we've learned something on how to evaluate expansion work using the equation, the general equation for finding work during expansion of the, of the control volume or the boundary, using work is equal to negative PdV. Note that some books are using work is equal to the integral of PdV only. That means that they are using the old convention that work is positive when work is being done by the system, and work is negative when work is being, done by the surrounding to the system. But we are using now the current convention, which is this one. Thank you.